Welcome students. Today is our lecture number 8. In this lecture we are going to study one or two more numericals about Lam's theorem. The most important thing is that you have to calculate all the possible angles. Okay, so you must know about parallel lines, corresponding angles, alternate angles, radius and tangent are perpendicular to each other, okay, etc, etc. You must know about how to draw parallel lines, how to create Z such that you can find alternate angles, such that you can find vertically opposite angles. Okay, so let us start with the numericals of Lam's theorem. But remember, this topic is very tough. You have to need some more practice and more practice. So let's see. So let us see some more numericals based on Lam's theorem. See, here it is the important example number 6. You can read the data first. A weight W is suspended from the ceiling with the help of a rope as shown in figure. Okay, so check the figure. This is the ceiling AD and a weight W is over here. It is suspended with rope AB from the ceiling. Now from B to C another rope is connected and at point C 100 kN force is attached. Similarly, a rope CD is also tied up with the ceiling. Some angles are also given in the figure. What is our target? To find the value of weight W. Okay, so this is the most important example. We have to calculate weight W. Now see, here there are 3 ropes, first, second and third. So as many ropes, as many tensions. So 3 ropes, so there will be 3 tensions also. Okay, so now if you are considering point B, then how many forces are acting at point B? First one is tension in this rope, second one is tension in this rope, and third one is weight W. But all the 3 are unknown forces. So you cannot start with this point B by applying Lam's theorem because all forces are unknown. So what you have to do? You just have to go at point C. What happens at point C? There are 2 ropes, means 2 tensions, and third one is the weight 100 kN. But now this third force is known to you, so you can apply Lam's theorem at point C. Okay, so just start with the help of point C and draw a free body diagram like this. So what happens? This is point C, this is point C, this is the rope CD. So what is rule? Remember what is the rule? Tension is always going towards fixed point. So here D is the fixed point. So tension will be in this direction. So this is the force FCD. You can see over here, this is the force FCD. You can write tension T1 also or TCD also. Okay, similarly at point C, second rope is connected BC. So for point C, while we are talking for point C, B is the fixed point. So tension will be in this direction. So from point C, tension will be in this direction, that is FBC. Okay, and third one is the force 100 kN downwards. So this is the force 100 kN downwards. So these 3 are the forces acting at point C, FCD, FBC and 100 kN downwards. Now talking about angles. This angle is 60 degree already given in the figure, or you can find like this Z. So this angle is 60, so this angle is also 60, pair of alternate angles. So this is the 60 angle. Okay, similarly what is given over here, it is 30 degree. It is 30 degree. Now you can draw dotted line at point C and make a Z formation again. So this angle 30, then this also 30, means again alternate angles. So this angle is given to you 30 degree. Okay, you can check out point C in both the figures. So this is the simplified figure, means free body diagram at point C. Now you can apply Lam's theorem. Now calculation is very easy. For force FCD, what is the opposite angle? Force FCD, the opposite angle will be this, means angle between other two forces. So it will be 30 plus 90, total 120. So you can write over here FCD upon sine 120. Similarly, use second force FBC. Then the angle will be this 60 plus 90, means angle between other two forces, that is 150, FBC upon sine 150. Now third force is 100 kilonewton, so angle will be in between other two forces, this angle. Now check out this angle. This is the horizontal line. Total angle will be 180, but left side is 30, right side is 60. So minus out it from 180. So 180 minus this 30 minus this 60, so it will be 120. Okay, so 100 upon sine, sorry, it will be 90, so 100 upon sine 90. This angle is 90. You can calculate with the help of geometry. Now simplification, you are already knowing about it. Compare FCD with the last term, and with the help of calci you can find FCD. Similarly, compare second term with the last term, you can find out FBC. So these two are the forces now available. So tension in this rope and tension in this rope is ready now. Now what you have to do? Now again you have to use second free body diagram at point B. At that time when you are drawing free body diagram at point B, tension in this rope is now available. So you can solve for the value of W. Okay, let us see how. At point B, what happens? At point B, free body diagram will be like this. Vertically downwards, it is weight W. In this direction, towards the fixed point, it is force F, B, C. And this rope is going upwards, means the third tension is in this direction, that is F, A, B. Okay, so this type of free body diagram will be available for point B, and then after we will check out angles. Let's see. So this is the free body diagram at point B. So this will be FBC, which is now available to you 50 kilonewton. We have found out it earlier. This force is FAB, and vertically downwards weight W. As I said, the free body diagram is ready. Now how this angle comes? 30 degree and 45 degree with vertical. How? Let us see the previous figure. Okay, so this is the previous figure. In this you can check this angle is already 30 with x-axis. Okay, means angle between FBC and x-axis is 30 degree. You can draw horizontal line like this and making Z like this. So this angle is 45 degree, this angle is also 45 degree. So now this force FAB will be making 45 degree with horizontal as well as 45 degree with vertical. Okay, hope you are clear with this. Let us see in the figure. So this is the figure. This angle is 30 degree with x-axis of rope BC, and for the rope AB, both the angles are 45 degree as I said, weight vertically downwards. Now applying Lami's theorem, if you are taking W, then angle is in between other two forces. So total angle will be 45, 90, 30. So it will be around 165. If you are taking second force FAB, then the angle between other two forces will be this, means 60 degree. Okay. If you are taking last force FBC, which is 50, then the angle is in between other two forces, means from this to this force. It will be 45 plus 90. So 135 plus, 135 it is. Now with the help of calci, you can compare first and last, second and last. So you will be getting W and FAB there. So here is the example. So with the help of two free body diagrams, you can find W. So this is the complicated sum, or you can say lengthy sum, which uses two free body diagrams. Let us see one more example. This is the most important example, in which you can check out one sphere is resting on the inclined plane and some angles are given in the figure with vertical and with horizontal. Weight of the sphere is 1000 Newton. Check out the data. Roller of weight 1000 Newton rests on a smooth inclined plane. It is kept from rolling down. It is kept from rolling down means prevented from rolling down the plane by string AC. So this is the string AC. Okay, you can check the string AC. Find the tension in the string means find this tension T towards the fixed point in the string and reaction at the point of contact D. This is the point of contact D. So what is the rule? Reaction is starting from this contact point and passing from the center. So this is the direction of reaction of contact point D, RD. Let us start drawing free body diagram at the center of the sphere. So suppose this is the center of the sphere C. So this point is C. String in this direction, so tension will be in this direction. This is the tension T. Weight 1000 always acting downwards. So this is the weight acting downwards. And from point D, reaction will be in this direction. So from point D, means from point D over here, reaction is passing from the center. This is RD. So it will be the free body diagram. Now checking about angles. Now angles are more complicated over here. Please concentrate on the angles. This angle is 45 with vertical. This angle is 30 with horizontal. And in between that, there is a small angle which is 15 degree. Remember this is written 15 degree. Now, let us check the simplification. From point C, draw a dotted reference line. Okay, this is again a horizontal line. By making Z, you can get like this. So this angle is 30, then this angle is also 30. Which is 30? Which is 30? In between tension line and horizontal line. So check over here, this is the tension line and horizontal line. So this angle is 30. So remaining angle with vertical is 60. Hope you are clear with these angles. Now what about this 45? How it comes 45? Let us check. Now for this 45, you have to do some rough work there. Let us see how. There are certain methods, but I will show you one shortcut method. From point C, draw a horizontal line and complete the triangle like this. Then what happens? In this triangle, total angle. What is the total angle? It is 60. It is 45 plus 15, 60. Upward angles. So this angle is 90. So this angle will be 30, which is drawn over here. This is 30. But it won't helping in getting 45. So now what? We have to find the angle between this reaction force and horizontal line or say vertical line. So we have to find this angle. Okay. So for that, just concentrate now. I am changing the color now. You can see if you can draw a horizontal line from point C, then by extending this reaction line RD, these two angles are alternate angles, vertically opposite angles, so they are same. Similarly, if I am extending this horizontal line, then I am getting this triangle. This angle will be 90. Again see, extending this line. Now this is radius tangent 90 degree. This is radius tangent 90 degree. So this angle is also 90 degree. Concentrate, the angles are very difficult. This is the radius line. So this is the radius tangent 90 degree. Extending the line, this angle is also 90 degree because of straight line. Now in this triangle, this angle is 90. So this angle is 45 and this angle will also be 45 degree. Okay, are you getting this 45 degree? Now what happens? Now by drawing horizontal line at point C, again red color line, then this angle and this angle will be same. Why? These two lines are parallel. So if this is 45, then this is also 45, which is over here. Okay, so this is the main important thing, 45 degree. So by applying 45 over here, this is also 45, vertically opposite angles. So this remaining angle is also 45. So basically what happens, you have to do a practice first. So for the force T, the opposite angle will be in between other two forces, means this to this, 135 total. So t upon sine 135, we will see in the calculation next page. If you are taking RD, then the opposite angle will be in between other two forces, means this to this, 30 plus 90, 120. If you are taking 1000 Newton weight, then the opposite angle will be in between T to RD. So this total is 180 minus 30 minus 45. So it will be 105 approx. So this angle will be 105. Check out the calculation on the next page. This is a simple method. Now you are knowing about Lame's theorem. So this is the calculation. T upon sine 135, RD upon sine 120, 1000 upon sine 105. You can go back and check the figure again. By comparing first and last, second and last, you are getting T and RD. So this is the tension in the string and reaction at point of contact D. So these two are very most important examples. Okay, you can check out again, practice these sums. Now what happens, this topic is so lengthy that such type of more and more numericals are possible. There are lots of design in which you have to find angles, you have to find forces. So what you have to apply, you have to apply your knowledge about geometry only. So as much as you can apply the geometry, then you can find the angles easily. Okay, so that's it for the today's lecture. If possible, I will come with some more examples about this topic, or we will start with the next topic. Thank you.